Concentration of a solution, it is the amount of solute dissolved in the given amount of solution. Now, the concentration of the solution can be expressed in two ways. First is a qualitative way and second is a quantitative way. Now, by the qualitative way, we means that we are not going to specify any numerical or any numeral value over there. We will just say that it is a dilute solution and a concentrated solution, right? That means we are telling about only the quality of it. Now when the solute amount will be less, we will compare to that of the solvent, we will say that it is a dilute solution, and when the quantity of the solute is going to be greater, it will be known as concentrated solution. Now here is a restriction that dilution will be up to which limit, and the concentrated we will say from which limit, right? That means we are not specific about this. So we switch to the quantitative expression, right, which is more specific. Now there are different ways of expressing the concentration quantitatively. Now just have a view of it. Now the quantitatively, the expression terms, we have first the mass percentage, then we have the volume percentage, mass volume percentage. Right, so here we have got the percentage terms which will be related with the 100 grams or 100 ml, right, and here again the 100 ml of the solution, right. Then the second next expression is the parts per million, ppm. So whenever the concentration of the solute is very less, so we can say the solution quantity is very large, that time we express the concentration in parts per million. Then we have the next term which is the mole fraction, right, parts per million, mole fraction. And the next is the molarity, right, it's related with the number of moles. This is also related with the number of moles. The next is the molality, and then we have got the normality. So mole fraction, molarity and molality. For calculating this, we have to first find out the number of moles, and next is the normality, right. Here we get the number of gram equivalents. So we are going to discuss them one by one. So the first term is mass percentage. It is the amount of solute in grams dissolved per 100 gram of solution, right. So here we can take the example that if it is written that 10%, right, of NaCl, right, by weight or by mass. Now what does it mean? It means that 10 gram of NaCl is dissolved in 100 grams of solution, right, that is the water, right, aqueous state. Now the second is the volume percentage. Now here it is the amount of solute in centimeter cube dissolved in 100 centimeter cube of solution. In this case, both solute and solvent will be in liquid state, right. We can take 10% of ethanol solution. So here 10 centimeter cube of ethanol dissolved in 100 centimeter cube of solution, right. Now third is the mass volume percentage. Here it is the amount of solute dissolved in grams dissolved in 100 centimeter cube of solution. Right? Now if I'm expressing it as 10% of NaCl, right, in water, and the relation is given by mass volume, right, W hash V or mass volume. In that case it will be 10 gram of NaCl dissolved in 100 centimeter cube of solution. Right? So here the mass percentage, volume percentage and mass volume percentage. Now the next one is the parts per million. In short we write down as ppm. Right? So what is parts per million? It is the amount of solute dissolved in large amount of solvent, right, and expressed as the quantity of it in parts per million parts of solution. Right? If we take example of seawater, in the seawater you know that the seawater, the amount is infinite. It's a very large amount. So here if we have to find out the amount of the chloride ion, so we are not going to specify it in terms of percentage or grams. It will be in terms of parts per million. Right? Now next is the mole fraction. Student, it is very important, that is the mole fraction. Right? It is expressed as X, which is also said as chi, CHI. Right? Now what is the mole fraction? To find out the mole fraction, first we should find out the number of moles. Right? Which will be calculating by given mass upon the atomic mass. On if it is a compound, it will be molar mass. Right? Now to find out the mole fraction, right, we have of a component, we have to find out the number of moles of a component. Right? Now if we have to find out the mole fraction of solute, right, I am expressing it as mole fraction of solute, chi solute, right, it will be number of moles of solute upon number of moles of solute plus number of moles of solvent. So until unless we find out or we calculate the number of moles of both components, it will not be possible, or at least one component we have to find out the number of moles, other also, because at the denominator we need both the moles. So number of mole of solute will be equal mole fraction of solute will be equal to number of mole of solute upon number of moles of solute plus number of moles of solvent. Okay, now in this way we have calculated the mole fraction of solute, right? Same way we can find out for the mole fraction of solvent. So what it will be? It will be number of moles of solvent upon number of moles of solute plus number of moles of solvent. Right. So you can now define that what is a mole fraction. So mole fraction is the ratio of number of moles of one component to that of total number of moles in solution. So in the solution we will have the number of mole of solute and number of moles of solvent. We are going to add it up, right? So here the chi solvent, that is the mole fraction of solvent, and the mole fraction of solute. So when we are going to add it, mole fraction of solute plus mole fraction of solvent, right? It will be always equal to 1. This is important, that the mole fraction of solute plus mole fraction of solvent will be always equal to 1. Their sum will be always equal to unity. And if one of the mole fraction is known to us, right, we can find the other one just by subtracting the mole fraction of that component whose value is known to us. So student, it is one of the way, right, to express the concentration of the solution. Just first finding out the number of moles of each component. Now since we are studying the binary solution has got the two components, one solute and one solvent. So to find out the mole fraction, first we should find out the number of moles of solute and number of moles of solvent. Here N stands for the number of moles of solute and solvent, right? And the sum of the both will be always equal to unity.